Okay, so we will talk about inheritance, and we will cover inheritance. We will cover the protected access specifier. We will cover constructors in the context of inheritance, and then we will cover class function overriding. Okay, so okay, so if you have a photographic memory, then you already know what I'm going to talk right with that previous image. If not, then I'll still talk about it, right? So we go ahead and talk about our bank account class, and we've been developing this class for a few weeks, right? We have bank account, and it has, we'll just deal with balance. We know we have the other private data, but I don't have a lot of space to write. So then we have public display balance, and then we have deposit, and then we have withdraw. So this class is right now like considered a base class, a parent class, a super class, or a generalization. I think that's the correct spelling. In the banking domain, right, when we're talking about accounts, then bank account can mean a lot of different things. In that context, it could be a savings account, it could be a checking account, it could be a money market account, which is a type of checking account, maybe even like a CD, savings, a mutual fund, right? So you get the idea, right? So that's why we say that the bank account is a generalization, and it generalizes a bank account, which can be considered like the abstract or the base generalization of bank accounts, right? And then from there we can derive, like I said, a checking, a savings, which we'll be focusing on today, right? Not the other types. So those other types can be considered like if we have a bank account class, and then we're like, well, I mean, maybe from this bank account class we can derive a checking account and then a savings account. So then we're like, okay, so then we can derive a child class, a subclass, and then these ones are usually a little bit more specialized. Like, for example, if we create a savings account class, from bank account, then savings account inherits display, deposit, withdraw, balance, and any functionality that exists in the bank account class. And it can expand on that functionality. So maybe in this bank account we do not account for interest earned, and then in savings we do. So we write specialized code that is specific to savings account. So then that makes it a specialized bank account class, and it's a savings account class. So that's the concept of inheritance, right? So you have a base class, and it's set up in a way like I have that it can easily be inherited from to create a savings, and then we will also create we'll create checking, a checking account. So when I say that we inherit, then by default savings will have the display, I know it's display balance, right? But I didn't have room to write that. And then deposit, I'm not writing the arguments, but that's okay. And then withdraw. And they do not have direct access to balance, so we don't show it here. And the check-in also, the check-in will also inherit display and deposit and withdraw. And if we wanted to extend savings, then maybe we could add like get balance with the interest or something like that, right? And then for checking, maybe there could be like some extra functions, like maybe to calculate like points for using your debit card or whatever, I don't know, right? Something like that. So questions here? Base, parent, superclass. Well, base, parent, and superclass are the same thing. And generalization is like the theoretical portion of inheritance, right? So if you read the recommended readings, which were the second half of chapter 11, the one dealing with inheritance, then they talk about generalization. I think they use the insect example, and then like specialized would be like some type of insect, right? So generalization and specialized is the theory behind inheritance, and base, parent, and superclass is what you'll hear depending on the languages you're working with, right? So C#, Java, or C++. I think Java uses the superclass, subclass. C++ I think uses base and derived, or parent and child, but it all means the same thing. So any questions here? Make sense what we're trying to do? We're trying to create this hierarchy, right? And remember, when we started object-oriented programming, we said that we model domains, right? And this is a small subset of the banking domain, but we are modeling something, right? So there's like a model, right? We have the bank account, savings, and checking account. So that's our model for our banking domain. Let me move this over here. How do we write the code to inherit? Well, you'll be surprised that it's actually very simple, but the concepts, we have to make sure we are aware of them and we understand them, okay? So let me see here. Yeah, I always get them confused, right? I think you all are supposed to be Gonzalez ACC1, but I guess I always get confused. So let me use the other one, this one. Okay, let me close all, and then we go here to savings, and from now on, anytime you work with classes, you have to create the header guards, right? So for your assignment for this week, do not forget the header guards. If not defined, savings account header, define the savings account header, and if we have to include bank account because we will need it. Okay, so we create a new class. How did I do that? I like this camel case method. So savings account, and then we will inherit publicly from the bank account class. Oh wait, I don't know how I did that. Okay, so, and I usually like the public on top, mainly because as a developer, like I want to see how this class can be worked with, right? So I want to see the public at the top. Okay, so what do we just do? We said I want a new class that inherits from bank account. Public means like keep the public access public. So whatever bank account has public, keep it public too over here, okay? And there's protected and private, but in this class, since it's an introductory course, we don't deal with those. We just deal with public inheritance. Okay, so then let's go to main.cpp, and we will, since that's already in GitHub, right, I'm going to remove it, and then we'll focus just on what we have here. So we can create an example here. So let's see. And again, recall how constructors work, right? And then you'll be able to follow what's going on here. So we can say, I think for the other class, I used unique pointers. So I will use unique pointers here too, but maybe not for the first example, okay? So we can say, okay, include savings account, savings, and then let's look at the diagram. So I said if we inherit from bank account, we should inherit display, deposit, and withdraw. Okay, so we can verify that by saying savings dot, and get bank balance, right? But that one's public also. So we have deposit, get balance, get bank balance, and withdraw. So in essence, we inherited from bank account, and then we can say, oh, that's pretty cool. So let's say using cout saying, okay, I want to make sure that I have that included there. So we can say cout balance, and then we can say savings dot get balance, and we'll go ahead and run this. Balance of 0. So let me open the bank account header, and what happened here? Like, we don't have any constructors. So how did this work? What did C++ do for us here in the savings account class? In the context of constructors, it did something for us. Can someone tell me? It created a default constructor for us. That's why. And why did it create one for us? Because we don't have any constructors, and that's the synthesized default constructor, meaning we don't have any constructors defined. C++ gives us one for free. How does that constructor look like? It looks something like this. So it doesn't do anything, but it allows us to create an instance of savings account. So let's walk through what happened. We execute this code. Compiler scans our class doesn't see anything, then it creates a constructor for us, okay? Creates it for us, and then it's like, oh, okay, so I'm going to fire off this one, and then by default it also executes this one. But notice that in the bank account class we initialize balance to 0. That's the reasoning for balance being 0 here, okay? So you all follow that? And can we validate that? Can we validate that that's what's happening? That C++ is creating this for us? Yes, we can validate that. So we can, for now, remove this, and then we can say, well, I want to create a constructor with one parameter. But then the question becomes, how do I pass this value B to bank account, knowing that savings account does not have direct access to bank account balance? We don't have access to that. We can't. Catching up. Sorry, let me move that. Okay. So we don't have access to balance, and well, let me try to compile here. So for now, I'll compile with this one, otherwise my code won't work. So build. So notice I don't have access, right? It's private, so I can't do something like this. So if you recall what I said here, is like, oh, so C++ is like, oh, I use this guy, but will it use this guy? Well, let's check, right? So let's see. I got savings account, and then we do that, and then let's try to execute. It appears we're okay. So then we go here, and then we're like, okay, so let me do this. Let me build. I'll go back and answer the question that's there. Hold on. So everything looks okay, right? So let's run it and see what happens. Run in terminal. Balance is still 0. Well, at least we got through like running the code, which is good, right? So this is good. This is good. But going back to my original statement, like what happens if we add one constructor ourselves? Can we create and run this code? And right away it's telling us no. And why? Let's try to run it. So we removed this constructor, so that means C++, once it sees we have one, doesn't add it for us automatically. We have to explicitly add it. So then once we do this, then our code compiles. And this goes back to the synthesized constructor, and C++ is like, well, you created this one, so I'm going to leave all the constructor creation to you. And we're like, okay, I'll create it by myself there, okay? Now the question is, how do I pass the value of B to bank account, right? And we want to use this constructor somehow, and we should be able to use it. So then we're like, well, okay, so what if I say, okay, so bank account B. So I use the bank account constructor. Why can I do that? Because a bank account instance will be created when I create an instance of savings account. That's only logical, because otherwise how would I have access to get balance? An instance of this has to be created in memory, right? So then we're like, oh, okay, so now when this executes, what I am expecting, and I have a value here maybe of 100, this constructor will be used. B is 100, bank account constructor, pass in the value of B, comes here, bank account B, 100, balance, which is 0 because we initialize it to 0, is not 0. Instead we change the value from 0 to 100, and now our balance should be 100. So let's go ahead and check that. So balance 100. Okay, why am I not creating a test case? I just want to make sure that we understand the concept first. Okay, once we understand the concept, then we can go and write the test case, right? Because I know class concepts can be difficult to catch on to. So any questions here? Let me see. So it inherited the constructor functionality from bank account class. It does, right? Because it inherits from bank account, right? I know that over here I said that it inherits the functions, right? Because that's what we can visually see. But it also has access to the constructors and it uses them, right? So in essence, yes, it inherits them. Can you use a pointer? Unfortunately, to pass a value, the way the code structured, no. So questions? Okay, so far no questions, right? So now that we have this code and hopefully now we understand how the constructors are working, let's go back to main and let's use, let me move this up here. Let's use smart pointers. Unique pointer, make unique, so this is how we do it, right? So we say a unique pointer of savings account will be equal to make unique. Make unique is what creates dynamic memory for us, okay? Make unique savings account type with initial value of 100. And once we start working with pointers, remember I said we need to, I don't think I said it right. Well, we need to make sure we don't use the dot. Instead we use the arrow operator, and notice how the arrow operator dereferences the pointer for us and allows us to call the functions, right? So that's why this code right here is not working. Now once we use the arrow operator, now C++ understands what we are talking about. So anytime you have a class that's created with dynamic memory, you have to make sure you use the arrow operator, okay? And when we run this code, notice balance is 100. Let's create a different one here. without sending in a value, right? Meaning using the default you manually create a constructor that we've created. So unique pointer of savings account type, savings, make unique. Actually, let me do this. Let me copy this here. And then what I'll do here is I'll just reuse it. Okay, so I do not want to send in a value, but I still have to use the open close parenthesis here. That means use the default constructor we've created. Which one? This one right here. And then we can say get balance. Okay, so this one should display 0, this one should display 100. And we can go ahead and run it. Let me see. Actually, I shouldn't be doing that. Sorry. I'll do this. Okay, savings 1. Savings 1. Okay. Running terminal. Okay. So notice now we can create an instance of savings with a 0 balance, and then we can create an instance of savings with begin balance. Okay. If we had more constructors, like a bank account had more constructors, then and we wanted savings account to use them, then we would have to add them here. Okay. Okay, so let's go back to the agenda. So where are we? I know I was going to talk about protected access, but I have to talk about constructors first, right? So we've talked about that, and we can see that they work just like a single class constructor concept, but now we have to map them back to the base class. What does that mean? This one has 2 constructors. Now we need to have 2 constructors, right? Because we don't know, like savings account class might be created with no begin balance or with a begin balance, just like the bank account class. So we want our savings account class to work with the bank accounts constructor. So that's what we've done here. Okay, that's what we did here. Okay, if we go back and look at bank account, we have private and public. In the agenda, now we talk about protected access. So meaning we can have access specifier that's protected. When you have the protected access specifier, this concept allows derived classes to have access to anything that's protected. So if we move balance to protected, now savings account has direct access. So this balance would also be over here. And I think the asterisk is the symbol for protected access. I'm not sure. But then over here, savings would have access to it, but main and test cases would not have access. Okay. So that's important to understand. So if something's protected, derived classes have access to it. Let me go to the diagram. So this one has access, this one has access, but not main code or test case, the test code. These wouldn't have access to balance because balance is still private. The only reasoning for adding protected is so that derived classes can have access to private functions or data of the parents class, right? For now, well, I guess we'll go ahead and do this. Okay. So any questions here? Please make sure that you understand how protected works, because you will be asked in quizzes like where protected can be used, right? So simple answer is in derived classes. Anything else, you can't, okay? Like main or test case or free function, right? You cannot. So questions here? So you might, okay, question, can bank account class still access the data and protect it? A class will always have access to its own public, protected, or private access specifiers 100% of the time. So can we still see balance? Yes, this one's not erroring out. So yes, the answer is yes. So you might, next question. So you might set the balance as a protected data and then read it with a get method on the derived class. Well, the get balance is already here. So if we wanted to create another function, then we could. But for now, we can still access it via the get balance. Right, so with that change, the simplest solution is, well, let's see if this code still works. Run it. And we have not broken anything. Okay, so that means that's good. We'll eventually go to the test cases, right? But these concepts are kind of involved, so I always just focus on the code, and then we'll go and modify the test cases. Okay, so nothing much to be said about this ones, right? It's just kind of like, okay, so what's the new rule? Oh, protected means that derived classes have access to it, but not main or not a test case. And we're like, well, are you sure? And we're like, well, let's go to main. And let's say savings of 0, balance. Inaccessible. Okay, so if it's not accessible in main, it will not be accessible in the test case. Okay, so that just proves that. So then here is kind of like, well, now do I have access to balance? Just to see what happens. And notice now we're not getting a warning, we're not getting an error. So now we have access to balance. And that's because we moved it to protected access specifier. I don't want to do this yet here, okay? Okay, so now we come into the agenda and we look at class function overriding. So let me see here. What can we override? Well, and what is override anyway, right? So override means that we get a base class function and we redefine it in the derived class. So we come here and then we can say, okay, so get balance, I will redefine it. How? Maybe we'll hypothetically add some interest, and then we can see where that gets us. Okay, so let me see here. I have the it's here. Okay, so what did I do? Okay, we just created a silly example. We were just like, okay, so let's since we want to make sure that we follow the theoretical portion of this piece, where we say that bank account is a generalization, savings is a specialized form of a bank account. So here, let's say, well, when I get balance for savings account, I want the balance plus any interest that I've earned, hypothetically, right? So we're like, okay, let's do that. And we're like, okay, so then I can say bank account balance will be 0.05 times, say this is what's today, April, so we want the balance as of March, I guess, 3 divided by 12 plus, or we can just use balance and it'll still know what we're talking about. And then in main, we can execute the code and see what happens. So run in terminal. Let me see here. What did I mess up? Return, right? Nobody reminded me. Okay. And we run it. Okay, so this is integer, right? So any decimal is stripped off, but at least we know that we had a begin balance of 100 and now it's 101. Maybe we executed with like 1000, right? So we can get a bigger number and we run it. Right, so again, the decimal piece is not included, but that's okay. Like our example is, oh, so then this code didn't execute, because if it did, then it would just return 1000. So then the overwritten function executed. So that's why we have this instead of 1000, and we're like, well, are you sure? Well, let's remove this code and then let's run it again. Run. $1,000. Oh, so you notice if we use the concept of overwriting, then we can make or write code in the derived class that's more specialized to this class. In this instance, like return the balance with the interest, right? Just a very simple example to show us that we can overwrite functions. And one thing here that I meant to do in the other class, no bueno, not good, right? This is not good. Like, we should not be hard coding code here. Like, there's no way we should be doing crazy stuff like that. So instead we can go, okay, so double. I know nobody pays 5% interest rate, or very few banks pay 5%, right? But this is just an example. Okay, so then we can say, okay, initialize it to 0.05. I mean, we could make it static, right? But for now, that's okay. And we don't want this to change, so then we make it a constant, right? And then we can say, okay, interest rate. And then this one's kind of lengthy, and we know balance is which balance, the bank account's balance. So we don't have to prefix it with the class name, and it still knows that it's the balance from the bank account. Yeah, so then we go ahead and run it again. And notice we have overwritten the get balance from the base class, and now our savings account is a little bit more specialized. Questions here? Okay, just to go back on the protected access, notice that if I move it to private again, then this code will break, right? So if I try to run my example, then it doesn't execute. I get errors, right? So, and if I go in here, it's going to tell me that the balance is private. Okay, so that should make it very clear that if we have protected access specifier, then that means derived classes can have access to anything that's in here. Okay, and then I can come back and I run it and it'll execute correctly. So we're good, right? Questions? And maybe we don't like that either, right? Like using literals, or the term is hard code. We don't want to hard code, so we can just say time, and then we can say 3 divided by 12. Oops, we have to initialize it. In a real program, we would have some code that would inject this in here, that would initialize it, right? Like it would get the time and or the month, current month of the year, and then we'd use that, right? But for this simple example, that's good enough. We go ahead and run it again. And what happened? Messed up something. 3 divided by 12, const double. I need to do that. Okay, that's weird. Like I go over here because I guess because this is double, it converts everything to double. Okay, that's why over here 3 divided by 12 worked, but not over here. If I just do 3 divided by 12 without 0.0, then it's doing integer division and it's 0. So I have to make sure I put a 0.0 so that it uses the rule that if it's double, then integer gets converted to double before doing the arithmetic. Okay, pretty cool stuff, right? Okay, so we've gone and executed this piece. So now let's go ahead and write the code for checking so that we can derive a new class, checking account. So we go here and then we're like, okay, where's checking? It's right here. Again, first thing, header guards. And if, okay, and now include bank account. And then we can say create a new checking account class, public lowercase, bank account, semicolon at the end. And our code should work just like this. So if we go to main, and then we're like, okay, so let me make sure that I put savings here and here. And then down here, I'll say, okay, let me create a checking account. Has no idea what checking account is. So I can include checking account. Checking. We'll start with the same example that we did for savings, okay? Cout, checking balance, checking, get balance. Add a new line there. And we can go ahead and run this example. So 0, and again, it's the same concept, right? The same thing happened. Like, we don't have any constructors. C++ creates one for us in the public access domain. So we go checking, C++ creates something like that behind the scenes for us, right? So if we run this code, it'll still work. But now we are explicitly creating the constructor, just to show you that that's what C++ does behind the scenes, right? So it still works. Now, if I want to create a checking account with a begin balance, even though bank account already has a constructor with one parameter, checking account doesn't. So you can see it's frowning at us. It's like there's no constructor that matches this, meaning there's no constructor in the checking account class that takes an integer. We can fix that. And then just like we did for the savings account, we can call the bank account constructor and pass B to it. And once we do that, if we go back to main, it's happy with us, and we should be able to run that example. Notice down here, checking balance 100. C++ does, the question is, can we inherit from checking and savings? Yes, but in this course we don't do that. We just want to focus on the basic inheritance, and I think you don't do that in data structures, but if you take that, I don't think it's required, but there's an advanced C++ course that builds on these concepts right here. There they might go into multiple inheritance. So, other questions? Okay, so we go back to the diagram and we focus on this specialized word, meaning we can add more functionality to savings or to checking. So say, I think I had created this yesterday, get balance with interest, but we've already done that, right? So maybe we should just say get interest earned or something, right? Just to show you that we can write a function that exists in the derived class, but not in the base class. So then we can say get interest earned. Get interest earned, and then we can just say like something like this, right? And I better not forget the return, get some weird value. So now in essence what we've done is we've added more specialization code to our savings account class. And if we go to main, then we should be able to say cout savings 1, get interest earned, and we can run that code. And notice it returns the interest earned, right? Just a simple example to show you that we can add more functionality to our derived class that doesn't exist in the bank account class. And how can we prove that? Okay, so we can say, well, bank account A dot, notice deposit, get balance, get bank balance, withdraw. B dot, get interest earned, get bank balance, get What if I want to say A equals B? A dot. Okay, so what am I trying to show here? Deposit, get balance, get bank, withdraw, right? So now I'm like, well, will this work? Well, the quickest solution is, well, if we don't see anything there, like any marks, then we should be okay, right? So, well, here we're not trying to add them, right? We're just trying to say that we create 2 copies of our user-defined types, and now we want, I think you're getting confused with like if we would do something like this, plus C, right? If we would have a third class. But now we're just trying to assign B to A. So I'm like, will this word produce error? Meaning, if I create a bank account instance and a savings account instance, then implicitly I should be able to save B into A. I should. So we're like, okay, well, let's try to build it. And it works. The problem is, well, then maybe I need to start with some values here, right? Just to show, because otherwise all of them are 0 and we're like, well, is it working or not working? Okay. So we're like, okay, we create a bank account with 50, and then we create a savings account with 500 begin balance. We save B into A, and then we're like, okay, C out A get balance. Let me add a new line over here, and just bear with me. I'll get to the point I'm trying to make, okay? So then we're like, okay, so what happened? Okay, so A, $50, B, $500. Copy the class B into A. The compiler does its best to help us, and we know we did because look at the balance. It's 500. A dot, but notice what happens to A. We have deposit, get balance, get bank balance, and withdraw. For B, we have the same ones: deposit, get balance, get bank balance, get interest earned. Oh, A doesn't have A interest earned. So notice what the C++ did. It's like, okay, you want to save it, yes, but bank account does not have enough functionality like savings account does. So anything that is not in bank account, you're going to lose. So that's called object slicing, right? Again, what's happening here with the picture may be better. We have an extra function, get interest rate in savings, does not exist in bank account. We create we create an object of bank account type A, and then we create an object of savings account type B, and then we're like, A is now equal to B, which is savings account type. The compiler's like, okay, but I'm not going to give you the get balance or get interest earned. but it still copies it. But we have to make sure we understand that. And if you think about it, that's behavior that we can't live with. Like, if we want to work with stuff like this, then how do we do that? First of all, do you all understand what's happening, right? Like, get doesn't have the get interest earned function like B does, right? This one, get interest earned. So meaning, even though this statement worked properly, almost, we don't get all the functionality that B has, which proves the point that savings account is specialized. But shouldn't we be able to work with something like this? Well, we should, right? I mean, because how do we get around that? So let me see here. Pointers. We use pointers, right? So if you think about it, let me see here. Same example, but we will diagram it. Okay, so we have the bank account. I'm not gonna write all the memory region for main, or we'll just assume that that stack region that I'm showing you is the main region, the main function code. Okay, I mean memory. A, and then we have a savings account. B, there's no heap memory, all of this is stack memory. And just to show you, say this is the main region, okay, of memory. And then we have some memory here allocated. And let's assume that A got 1, 2, 3, 4, 5. I'm just gonna choose 4. Got 4 memory blocks, right? And then savings got 1, 2, 3, 4, 5. Oops, let me use a different color. So this is A. This is B. So hypothetically, write 4 memory regions and 5. So that's just like a very simple explanation of what happens when we do A equals B, right? So if we say A equals B, now what we are saying is you try to stuff all this into your fewer memory slots. So then maybe it's like, oh, so that's why it's not working. So how can we get around this? And the answer should be, well, hopefully with pointers. So we're like, okay, so I don't want to use unique pointers, so I'll say, okay, what if I say bank account A pointer equals new bank account with begin balance of 50, and then I'll say savings account pointer. We have to use a pointer to create dynamic memory, right? Savings account. And then I'm like, okay, well, will this work? Probably not. But what if I'm like, okay, so well, let me think here. Bank account. Okay, there we go. So let's see, A, deposit, get balance, get bank balance, withdraw. B, okay, so we're in the same boat, right? So we're like, oh, so what's going on? So we're like, okay, so savings account. B, okay, catch up. Wait, did me spell it? Oh, say. Oh, I have one C. Okay. Okay. Savings account. B. Get balance. Okay, so what did we do? A equals B. A. So same situation, right? So this is what we will try to tackle in the next lecture, right? Like, how do we make sure that we can create different instances of classes and interchange them left and right, right? So we tried with static variables, didn't work. We tried with pointers, and so far we're like, well, we're in the same situation, right? So in the next lecture, we will tackle this problem and definitely solve it, right? So that, and the answers will be in chapter 15, I think. And it only has one C in the definition. Yeah, so I'll go back and fix that. Okay, so let me make sure I go back into the agenda. So inheritance, protected constructors, and class function overriding. And then we'll start off the next lecture tackling this issue, right? Which is like, well, wait a minute, we should be able to create objects and move them all over the place, but not lose functionality, right? So we will definitely tackle that in the next lecture. We have, what, 2 minutes? So that is it. There's no class assignment today, and make sure you read chapter 15. It's a small chapter, but it's very important. We'll talk about the concept of virtual functions, pure virtual functions. Virtual functions helps us implement polymorphism. Pure virtual functions will help us implement abstract classes, and you'll see how polymorphism helps unleash the power of object-oriented programming, right, with the help of pointers and the virtual function concepts. So if there's no questions, that's all I have for today.